In this tutorial we are looking at indices. So first we are going to focus on the basics of indice rules, and that is x to the power of a times x to the power of b is equal to x to the power of a plus b. Just some language that I'm going to keep referring to. I'm going to call these base numbers, and our powers are the indices. So for example, if we have 2 to the power of 2 multiplied by 2 to the power of 7, our base numbers are the same, so our base number is 2, and then we add across our indices if we are multiplying these base numbers together. So that's 7 plus 2, which is 2 to the power of 9. This can also be done with division, so x to the power of a divided by x to the power of b, and we're left with x to the power of a minus b, again where our base values are the same. So if we have 10 to the power of 6 divided by 10 to the power of 3, that's 10, which is our base value, and 6 minus 3, which is 3. Our next example is if we are using brackets. So for example, x to the power of a, and we're doing that to the power of b. That leaves us with x to the power of a multiplied by b. Here we have to be careful. For example, if we were to do 2 to the power of 4 to the power of 2. Now, writing out what this actually means, that's 2 to the power of 4 squared, so multiplied by itself. So what we're doing here is 2 to the power of 4 times 2 to the power of 4, so we can leave that then as 4 plus 4, which is 8. So we are left with 2 to the power of 8. Then looking at algebraic indices. And our basic indice rules. So first let's start with a to the power of 1 over b. So now we're looking at fractional indices. We root whatever the denominator is. Example being 49 to the power of 1/2. The denominator is 2, so we are square rooting 49, which is 7. Another example, 8 to the power of 1/3. The denominator of our fractional indice is 3, so we are cube rooting 8, which is 2. Another fractional indice is when you have a numerator and a denominator. Let's not call that a because there's too many a's, so we'll call that x. So what we're doing here is we are still rooting whatever our denominator is, but you are then doing this to the power of the numerator. An example being 64 to the power of 2 over 3. So what we're doing is we are cube rooting 64, which is 4, and then we square that, which is 16. Negative indices. X to the power of minus a. A negative indice is the reciprocal. Reciprocal means the inverse or flipped, or 1 over. So that's 1 over x to the power of a. An example might be 2 to the power of minus 3. This is 1 over 2 cubed. 1 cubed is 1, 2 cubed is 8. Our answer is 1 over 8. Now what we will see in exam papers is a combination of these rules. So let's look at an example. 4 over 9 to the power of minus 1/2. First we're going to look at our negative indice and finding the reciprocal of 4 over 9, which is flipping it upside down, 9 over 4 to the power of 1/2. In doing this, it makes your indice now positive. So this means a half is the square root of 9 over 4, which is square root of 9 is 3 and the square root of 4 is 2. Let's look at one more example. 125 over 8 to the power of minus 2 over 3. Start with the negative indices, so we are finding the reciprocal, so 8 over 125, and that's to the power of 2 over 3. Note a common mistake at this stage is that some people will flip the indice, which is not the case. So now we find the cube root of 8 over 125, and then we square it. The cube root of 8 is 2 and the cube root of 125 is 5, and now we square that, leaving us with 4 over 25. Occasionally we will get more complicated questions where we have to use our indice rules to look at it as an equation. So let's do an example. That's 16 to the power of 1/5 multiplied by 2 to the power of x equals 8 to the power of 3 over 4. Now what we're looking at here, what we first notice is that our base numbers, our lowest base number is 2, and then we've got 8 and we've got 16. Now, we want to change everything to have the same base number. So 8 is 2 cubed and 16 is 2 to the power of 4. So our first step is to change our base numbers all to be in terms of 2. So 16 is 2 to the power of 4, but that's still to the power of 1/5, multiplied by 2 to the power of x equals 8, which is 2 cubed, which is to the power of 3 over 4. Our next step is to use our bracket indice rules to expand those brackets and simplify. 4 times 1/5 is 4/5, multiplied by 2 to the power of x equals 3 times 3/4, which is 9 over 4. And what we're left with now is the first rule that we looked at today, which is when all of our base numbers are the same, you can add your indices together. So this means we can make up our own equation to be able to solve for x. So that's 4 over 5 plus x equals 9 over 4. To get the x on its own, we want to subtract 4 over 5 from both sides. So that's 9 over 4, take 4 over 5. When simplifying and subtracting with fractions, we want our denominators to be the same. So we're going to multiply our first fraction by 5, which is 9 multiplied by 5, which is 45, 4 times 5, which is 20. Subtract, second fraction we multiply it by 4, so we're left with 16 over 20. So our next step now is just simplifying across, that's 45 minus 16, which leaves us with x equals 29 over 20. If the question says simplify, then we would simplify that fraction down or make it a mixed number, but in this case it does not. So we can leave our final answer as x equals 29 over 20.